All right, good afternoon, everyone. Thanks for coming along to one of the last afternoon sessions. Not a huge turnout, but hope you're all interested in learning about some load testing. I'm going to keep this pretty interactive, so if you've got any questions throughout the talk, just put your hand up or shout out. This is mostly for your own benefit to learn about load testing and load testing within Tosca Flood. So the structure of the talk is mostly going to be talk a little bit about the methodologies around load testing, specifically around protocol level users and browser level users, and some of the tools that we can use that we associate with those methodologies. And then we're going to talk a little bit about analyzing the results that we get from running a load test. So during that, we're going to look at implementing protocol level tests with JMeter, which is going to be very, very exciting. And then we're going to look at browser level users, which is a new concept that we've come up with, which we've introduced with two new tools. One, which is Flood Chrome, which is a high-performance browser-level load testing tool, which is more in the Selenium space. And then we're going to look at Tosca Flood, which is probably why you're all here as potential or as Tosca customers. So then we're going to look at testing both APIs and a UI application, which is SOP Fiore using Tosca. So, load testing. What is load testing? And you might recognize this graphic from last Accelerate, but it's very, I think it kind of shows the impact. Load testing is essentially putting demand on a system and measuring what happens. And that's what we're going to do today. And the primary purpose of this is so that you can identify bottlenecks within your backend systems. So you might be putting load on one system at the front of your stack, and that's going to be interacting with a database layer or a caching layer or a queuing layer. And as different interactions within your system creates more work for the backend systems, you can identify bottlenecks which then impact the front end again. So that's primarily what we're trying to identify as we scale up the load of our systems. So we know that it might work with one user when we run a functional test within Tosca, and then we can scale it up to 100 users or 1,000 users or 10,000 users, or if it's an API test, potentially tens of millions of users, which is really useful if you're getting ready to potentially maybe launch a product to a very large audience. So we've got customers that work with, internet streaming TV or large sporting events, or even online ticket sales for very large artists, which get a huge amount of demand come in at first, and then you see, you hear stories of, the site went down and the tickets were sold out in 10 minutes or 30 seconds or whatever it is, or nobody could watch the live stream because the site was down because too many people were on there. So it allows us to simulate scenarios like that ahead of time. So then comes the question of when should we be load testing? And really the answer is continuously. This is the continuous testing graphic that you've probably seen around the ways. Essentially, you can begin load testing as soon as you have something to test. It's not something that you should do the weekend before you go live with your product. That's usually bad news. You've got to do it early enough in the cycle that you're going to be able to react to the results that you come up with. So if you decide to do a load test fairly early on or in the middle of your release, and you realize that it doesn't scale as you planned, there might be other departments within your organization that are responsible for the scaling, and that's something that could have lead times which you might not be able to respond to in time for launch. So it's one of those things you want to do early enough that you can respond to it. And really the benefits of this is similar to the benefits of most testing, which is that you want to identify problems before they become costly. But really, it helps you plan for future growth within your user base, or your customer base, or ultimately anyone who's using your application. It might be an internal application or an external application. It could be your core product. It could be an internal system used by all of your suppliers. This helps us identify what sort of capacity planning we need to take into account in the future. And ultimately, if you're working on a very potentially public application, it could potentially prevent you from a very colossal failure that's visible in public, which we occasionally hear about because They are, by their very nature, very public when a lot of people see them. Thanks, mate. So a brief history of load testing innovation. Can I get a raise of hands here? Who has done load testing before? Okay, so we've got about half the room. So traditionally, when you talk about load testing, if you've done load testing in the last 5, 10 years, you're most likely doing load testing at a protocol level, which is you're simulating traffic over a network directly by making network calls. So this is testing things like the HTTP layer, DNS or WebSockets, or even a streaming interface. Maybe you use a protocol, a network recorder to do record and replay, or a correlation engine which records the behavior between multiple requests and identifies things that need to be changed. But today, we're going to be introducing you to browser-level users, which we believe is really the next frontier in load testing, which is what this talk and this workshop's really about. So some of the technologies that have come along that have enabled us to do this in the very recent history, which is essentially browsers have become very, very fast. They've also become headless, which means that they can run without a user interface environment, which allows us to scale them on our load test infrastructure very, very wide. So we can launch tens of thousands of instances of a web browser and then simulate a user behavior running in that browser to create load, which abstracts away all of the knowledge that you need to know about the network layer. Which is really interesting because some of the biggest challenges that people are now facing in the load testing space is that applications are becoming more and more client-side. It's no longer just static HTML sent over a wire and rendered in a browser. It's now entire applications built in JavaScript which load and then execute and might stay living for a very long period of time through multiple user interactions. And testing this at the protocol level becomes really, really complicated, especially when the state that's pertained within that application might be computed from talking to multiple different sources. For example, something like an OAuth exchange where you've got to talk to an external API, pass a token over, something happens there and they send you back another token that you can use to make additional API requests. While it's possible to simulate that at the protocol level, avoiding that complexity breaking your application in the future becomes really, really tedious. So here is an example of what a diff of 2 requests over the network. So this is a simple JSession ID, which is basically, this is the difference between 2 requests. And you can very easily at the protocol level, pattern match this particular token, but each request that you make, you're going to have to sub this out with a real value so that the backend actually responds to the request correctly. Without doing that, after you make one request, it's basically going to be invalid for subsequent requests. So at the protocol level, things like this really build up. It's like death by 1,000 paper cuts. After a while, you kind of just want something that's a little bit simpler. And if you saw my Discover session earlier, you remember this slide. So, excuse me a sec. So one visit to Amazon.com makes over 300 network requests. If you're going to simulate this at the protocol level, this becomes really, really tedious, especially considering that those 300 requests are likely to multiple different servers. Excuse me a sec. So those servers could be CDN backed, or maybe you're talking different regions around the world. They can have different network characteristics. And again, the ratio at which those requests are made as people interact with the application is going to vary based on the actual functionality that's being tested. So it's not sufficient to just say, we'll record it and replay it continuously at a higher and higher rate because that doesn't create a realistic load scenario. And that was kind of one of the things that a lot of people, when they start out with load testing, think, I'll just look at my network logs and I'll create a load test from that and just replay it, and that'll be realistic enough because that's something that happened on my system. But the reality is that that's not something that you can measure in a realistic way and then make decisions off. A much better approach is to have a defined higher level abstraction, something like interacting with the user interface, which then creates those network requests in response to an action which you can actually reason about. So in our case, one visit to Amazon is making 300 requests. If it was a single page application, we might be looking at, you click a link or you fill in a form and it makes a network request for creating an order or updating a user account or something like that. So as our applications grow in complexity, we need to look at the right tooling to test that complexity. So in this chart here, I've got the level of abstraction on the left and the complexity of the application under test on the right. So as we go up in the level of abstraction, it allows us to keep a fairly sane understanding of our test while testing a much more complicated application. Whereas if we stay at the very low level of abstraction, we're only going to increase the complexity of our test as the complexity of our application increases. So with something like Flood Chrome or Tosca Flood, if we go back to the Amazon example, we can literally say in our test, open this URL and click this link, and then all of the complexity of the network is buried for us. Everyone's got kind of a puzzled look on their face. I hope I fill the rest of that in as we go along. So from the ground up, what are the best tools to use for this? And in the rest of the talk, I'm basically going to give you a demo of how all of these tools work, as I said at the beginning. So at the protocol level, the most common things you're going to be looking at is JMeter and Gatling. And I've put Tosca Flood in there as well because under the hood, we actually abstract away your test to run it as a JMeter load test if it's at the API level, which allows us to do the scale that we talked about earlier. In the browser level, we're actually running actual instances of Google Chrome. So again, the right tool really depends on what you're testing. At the moment, the APIs that we use are only in Chrome, but they are coming to Firefox very soon. So that is on the roadmap. I was glad you didn't say, can we do this in IE6 or something? So once we have the right tool, then we need to talk about the right measurements. So most commonly with functional testing, you're mostly concerned about a certain degree of pass and fail scenario. You want to know that your application is able to achieve a certain flow to a certain point, and that all works. With load testing, we're more concerned about how quickly can we do these things? What's our transaction rate and how many users are doing it? How many of them pass and fail as the load increases? And how long does it take a user to actually do that operation? So the protocol level, when we talk about something like response time, we're literally talking about how long does it take this network request to actually happen over the wire? So then you're concerned about things like DNS lookup time, the connection time, time to actually send the data back to your browser or to your load generator. So things like network latency play a huge role in that. But at the browser level, that's only a small part of the picture. Because we're encompassing all of the different interactions over the network into one interaction for the user, or maybe it's, click this link, fill in this form, fill in these inputs, press submit. So the user needs to be able to, what we're interested in, I should say, is how long does it take the user to actually fill those things out and complete that particular business operation. So it's kind of different orders of magnitude. At the protocol level, we might be talking milliseconds, tens of milliseconds. The browser level, we're talking seconds. So again, it comes back to what is our attack surface, as I like to say, which is at the protocol level we're still talking about HTTP, TCP, DNS, WebSockets and so forth. But the UI level we're talking about clicks, selects, typing, inputs, any other interaction that the user might interact with, a drag and drop, for example. So I think I've harped on about that enough so far. So let's talk about a test target. So for this demo, we have what we call our dog food API, which is a simple Swagger interface for an API, which we can do an API scan with in Tosca. And it just encompasses some basic functionality. So we're going to implement that in JMeter. I know you're really all super excited to see me implement that in JMeter, aren't you? I'm just kidding. I'm not going to even open it up. And then we're going to look at SOP Fiore. We're going to look at 2 different implementations of that. The first one will be the Flood Chrome implementation, which is a script-based load test, which is largely modeled off Selenium. And the second approach will be in Tosca Flood, which I'm pretty sure that's why everyone's here. So a bit more about the dog food API. It's publicly available if anyone wants to write tests for this later and play around with it. The URL is dogfood.flooded.io. And basically, it's got a couple of app servers behind it. I wrote in here that we have server-side monitoring set up. I'm not sure if I've ever seen it, but I'm sure we do. Yep, get thumbs up, thumbs down from Tim at the back. So it has some basic operations. You know, you can add a dog, you can find dogs by status, find dogs by tags, order dog food. It's really just a simple kind of CRUD interface. You know, create, read, update, delete. So let me switch over to that. The first one we're going to do, so we're going to do an API scan. So let me just make sure this is mirrored properly. Hey, there we go. So we've got Tosca here. And what I'm going to do is go to API testing. I'll launch our API scanner. And I'll just put in the URL for our Swagger definition for that API. And straight away we've pulled in all of the results, all the different API endpoints, I should say. So it's got all of the definitions we need to interact with this. So it's going to be really, really easy to turn this into an API load test. So let's export that as an API test case. Oh, I think I might have duplicated this. Let me just do that again. I only had one of them selected. Alrighty, so test cases. So let's take these and put them in here. I assume this is all a pretty familiar process to most people. That's a good question. I think in the case of the Swagger definition, it should do it all for you, so you shouldn't need to have any code level understanding of it. So a lot of APIs will expose a definition which the API scanner can pull in, so that saves you needing to understand the code level thing. If you're testing an API that might not be defined like that, then you would definitely need to be at a developer level. Which, yeah, I won't go into the specifics of it, but essentially all of the knowledge about the API has been encompassed in all of the modules that were imported. So when we turn this into an API test, which I'm going to do now by going to the execution list, we have a new option here, which is create load stream. Let's call it a baseline test. You'll see we have a new stream configuration tab. So a couple of things here. We've kind of set this up so that it's your one-stop shop to start a load test. So behind the scenes, Flood's going to take care of all of the infrastructure to actually launch the load. So we can basically select as many users as we want. We could go up to 1 million right here, or as minimum as 1. So for example, for our test case, we'll go with 1,000. And then we just select which region we want to launch this in. So we've got access to all of the Azure and Amazon regions. So I'm going to choose US West Oregon, which is kind of our go-to. And then we talk about user ramp-up scenario. So typically, the easiest thing to think about is you'll just kind of load the ramp up in a linear fashion. So that is that basically we'll take 0 to 1,000 users and distribute that over 60 seconds, as I've put in here. We could put in 120 seconds or whatever we want.
Basically, like the start of the workday, people showing up at different times, like for half an hour.
Yeah, it's a great example. Yeah. The other scenario is a stair-step scenario, which is kind of basically says we want to add, say 100 users every 120 seconds. So in this case, to reach our 1,000 users, it's going to take us 20 minutes. The other type of ramp up we've got is a stampede, which basically says take this many users, do it over this period of time, and then do the rest over another period of time. So it's kind of like a two-step situation. Excuse me. So for our use case, we're just going to stick with linear to keep this really simple. And there's a couple of things we can do with the timing. So each time our load test iterates, we can choose how the timing is affected between each iteration. So we might want just a constant, say, 1 second here between each step. Should be pretty straightforward. Maybe we want it random, so we want 1 second deviation for every other second. Might make sense to do, say 5 seconds with 1 second deviation. They'll keep it fairly random, or we can do a target number of users. So we can say that we basically want 1 transaction to complete every time this duration expires. So I'm going to keep this really straightforward and just go with constant timing, 1 second. And that's kind of a simulation of maybe a user completing interaction of some sort. So 1 second might even be too short. We're going to be running 1,000 threads doing this, so maybe 5 seconds makes more sense. And then we can configure some last minute scheduling things. So for example, maybe we only want to run this scenario 1 time or 10 times or whatnot. We can configure that here if we like. We can also just loop forever, which is essentially the scenario, so it'll just loop until the load test expires time-wise. And finally, we can set up a delayed start. So we might want to schedule this to run at 4 o'clock in the morning, or we might schedule it to run on the weekend or something like that. We can do that here by setting up what time we want it to start and when we want it to end. Right now, because I don't want to make you all sit here waiting for it to start, I'm just going to kick this off and we'll see what happens. Oh, I forgot one thing, the most critical thing. We need to add our test steps. So in this case, let's add the add dog. Yep. So this will be the endpoint that we're going to hit for this test. Let's keep it really straightforward. One example. And there we go. We've turned our functional test into a load test. This is going to take 3 or 4 minutes to spin up the infrastructure. Should have kicked this off before the talk, but anyway. Sure. Okay. So it was load and endurance. Yeah, absolutely. So I think that's kind of, you would tune that based on the combination of the number of users you're going to load up and the duration of your test, and then the timing between each step. So depending on the scenario you're trying to reach, essentially. Yeah, I should have repeated the question for the video, which was that can you configure for load, test, and endurance? Is that correct? Yes. Stress and endurance within that interface, and the answer is, as I said. So we'll give this a moment. So I'll talk to the API, so to the user interface here. So this is Flood's interactive dashboard. So we have a couple of different things going on. First of all, this is the kind of the start screen while a test spins up. But what's actually going on behind the scenes is that we're launching actual grid nodes, as we call them, which are servers within Amazon. So we calculate how many servers we need to launch based on how many users you've selected. So in our case, we selected 1,000 users, and we can roughly pack 1,000 users onto one server on Amazon for this type of test. So we can see here that we've launched one node. It's now up and running. It's got an IP address. And I pre-started a couple of nodes in Azure earlier as well, which we'll use in our UI demo. I guess go back to the test here. And in a couple of seconds, the results will start to stream in. So on Flood, we aggregate the results at about 15-second intervals. So every 15 seconds, you're going to see a live update of where your application is at as far as the data goes. We also offer the support for doing up to 1 second resolution, if you come talk to us about it. So here we go. It's initial report, so we've got 135 users as we're ramped up to, completing 71,000 transactions per minute. But it's a relatively fast API with a response time of about 18 milliseconds, so I'm really thrashing it. I don't know how long this is actually going to go once we get to 1,000 users. But yeah, we're burning through about 3 megabits of network bandwidth, so not a great loss happening. It's a pretty simple API. Once we have a few more data points in there, there'll be more of a story to go with it. So let me pull up one that I started earlier. This is the same test, essentially. So we've got our add dog method here. And we can see each one of these lines represents a different measurement. So these are the measurements I was talking about earlier. So we can add in, toggle which ones we want. So the main thing is this orange line here is our concurrency. So you can see the ramp up at the beginning. So we've gone from 0 up to 2,000 users. And doing about 250,000 transactions per minute, with still a reasonable response time of under 1/4 of a second. So that's still pretty nice. It's worth pointing out though that as we've gone up, we've reached a point where the failed transactions still a very small rate. We can see them starting to increase. It's only kind of 200, 250 compared to past transactions in the 220,000 range. But that's something to be aware of as your test runs. You might notice the sudden spike once you reach a certain number of users where transactions begin to fail, and that can indicate certain bottlenecks within your application. For example, your queue filling up, not enough background processes to process jobs and so forth. So from here, we can actually dig into viewing what's going on. So these are all of the traces we've taken of actual requests that took over the network. So if I go into one of these, we get the actual wire response of what was happening, similar to what you would see in the network panel within Google Chrome. We could also set up things like assertions and errors, assertions and extractions within JMeter directly through our test within Tosca. So they will appear in here if we make any expectations of particular results appearing, which can be really useful to assert that an error wasn't sorry. Makes it really easy to assert that an error wasn't appearing within the response when it correctly had the right response code. So sometimes it's not necessary to just say that you got a 200 response back because it might have the completely wrong response body to what you were expecting your application to respond with. So this makes it really easy to identify at which point those started to appear. So if there was any significant failures right here, we'd start to see some red markers here, especially if there was different response codes coming in. So we get a lot of 200 request OK, which is usually HTTP scenario for things going well. But we might have seen a lot of 500 errors coming in. So in that case, we want to know what the response body said in case it was an application error, or maybe it's an error at our load balancer. So I'm just going to go back to our test right now. And you can see this nice, steady, linear ramp up. Did an odd little bump there. So this time at 1,000 users, we're doing kind of about half the transaction rate we were doing in the previous test at 2,000 users, which is a pretty good indication that things are scaling pretty linearly for our application. So that's API load testing within Tosca. Now let's move on to something a little bit more exciting. So I mentioned earlier, and apologies for everyone who dozes off when they see code, but I'm going to show you a very quick example of a load generation tool which we've built called Flood Chrome, which is our high-performance browser-level load testing tool, which is designed in a similar way to work as Selenium, but it's a lot more lightweight and allows us to achieve a lot more concurrency than we're able to achieve with Selenium. So in our example here, I'm just going to open up. I think I already have it open. So we're going to be testing this SOP Fiore demo trial site. So this is a fairly complicated single-page application. That is that it loads kind of an application shell and then it makes a lot of requests to pull in the information for various customizations that the customer has installed. And we can see that quite a lot of traffic goes on. So even just looking at the AJAX requests, it's a fair bit of stuff going on, and a few errors as well. So testing that at the protocol level would be an absolute nightmare. And one of the unique things about SOP Fiore and applications like this, which make testing it at the protocol level really difficult, is that there's certain correlations which change with every single release of the application. So if we're targeting specific identifiers, they're almost always just randomly generated identifiers. So every time there's a new release of the product that comes out, we've got to go through our tests and figure out what the new value for all those identifiers is. Whereas if we're working at the browser level, we don't need to do that because we can literally target the same elements that the user would be interacting with. If we want to go to the inbox, we just find an element that says my inbox and send a click event to it. So in our example here, I hope this is fairly descriptive, but it's a very simple case of telling the browser to visit that URL. Then we're going to wait until it shows a terms of service page, which you didn't see because I've loaded up before, but the first time you view it, there's a terms of service thing you've got to accept. So we wait until that appears, and then we click accept on that, which all of these little interactions come into play, which we'd have to think about simulating depending on how the user is coming into the application. One of the cool features of doing browser testing is that we can take screenshots of each state. So if we're not entirely sure what's happening, we might be seeing arbitrary failures for some reason. We can take a screenshot, or we can have the test engine automatically take a screenshot on failure for us, which is really useful for debugging. It's kind of the equivalent of looking at what the trace was on the wire in the previous example. At the API level, we can see what the response was from the server. In this case, we're seeing what was actually happening on the browser. So when we run this, I'm just going to open up, go back to this one. So this is a really simple example, but we have or we don't have. It's an older one. Hold on a sec. It's a better example. So this is the SOP Fiore example that I'd showed you, that script running. And as the script runs, we can see we've got screenshots of each action. So we've got a fairly high error rate here, so it's failing to find an element, so it's basically timing out when it's waiting for an element. So this allows us to go through and see, okay, at that particular step, so this is the travel request home step, which is this one here. So we're waiting for a particular element, my travel request, to appear, which is what happens after you click on the travel request button. And for whatever reason, because of the application being too slow or the application showing an error message, when we're still on the original screen. So this makes debugging a lot easier than kind of just digging into what might have been happening on the wire when you've got an application that is as noisy as SOP Fiore. Well, yes and no. So, so we've got two options here. The first one is Flood Chrome, and the second one is Tosca Flood, which I'm going to show you in a moment. And in Tosca Flood, you never have to look at any of the code. The reason I wanted to bring this up is because there are some customers that still use Selenium, and it's important to recognize that you can now take your Selenium scripts and turn them into browser-level load tests. So it's there's a certain degree of reusability there now. It's also a lot more declarative to, I think, if you're familiar with working at a protocol level with a scripting language of any sort, maybe it's in Gatling or something like that. Jumping up to working at the browser level with something like this Selenium-inspired scripting language is a lot less effort than trying to script a really complicated application at the browser level, at the protocol level. So how are we going for time? All right. So that is Flood Chrome. Now for the grand finale, I'm going to open up our SOP Fiore project. I'm sure they can cut that out of the video. Cool, so This is much the same as what we had before. The only difference is we now have our GUI test cases underneath our load stream here. So we're going to execute one of the test cases, which is our order to cache example, which is just one of the operations within the SOP Fiore demo. I think this is actually hitting a real Fiore instance, actually. It's not the demo side. So this is, where do I import that to? So this is going to execute, create sales order, create outbound delivery, and create billing documents. So that's 3 of the different operations within that particular segment of SOP Fiore. And there's really nothing else I have to do here other than hit go. So we're going to quickly make sure that we've got our settings right. So we're going to do 40 simulated users. I've picked the same US West Oregon. And we'll just keep everything simple. So linear ramp up, 60 seconds. And we'll run it for 30 minutes. I'll go something a bit shorter. We'll just go for 10 minutes in our example. That's really all there is to it. It's just the same UI you would expect with the API load tests. And this is just taking a browser test from Tosca and turning into a load test. So it's going to start up 40 instances of Google Chrome. And then we're going to just run this scenario over and over again until we start to see the results come through as we ramp up the load. So I'll hit run. And straight away it loads up the flood dashboard so we can see the results coming in. Now I pre-warmed all of the grid nodes for this earlier, so we don't have to wait for those to start. We're straight away going to have our test kick off. It's probably going to take about a minute or so before we start seeing the results come in. The browser side of things is a little bit slower with Tosca, but we're still spinning up 40 instances of the Tosca execution engine. So it's literally running the same environment that you would be running for a functional test. We're just doing it at a massive scale. So we can scale this out really as far as you want to go, depending on how much load you want to generate. And Flood takes care of all of the scaling of the instances and servers behind the scenes. And you saw we only did in US West. You can launch load from multiple regions at the same time as well, which is really, really easy. Just select another region. And so if you do 1,000 users, for example, and select 2 regions, you'll effectively get 2,000 users. So I might go to one I pre-prepared earlier while that's spinning up. You can see the test is running here. That was our API test, and this is our SAP Fiore example. So you can see the results are a lot more noisier than before. You'll also notice that we're kind of working at a different order of magnitude as far as what we're monitoring now. So if we were to smooth out the concurrent users, we'd see we're achieving 40 users. But the response time that we're interested in now is essentially the time it takes to complete that entire interaction. So in our example, for example, order to cache, what was the step? Create sales order, for example. That's an entire business transaction which has multiple operations going on behind the scenes. So there's quite a few different network requests happening. There's filling in forms and so forth. So as that goes through, we're basically looking at how long does a real user actually take to run this. And in our case, the timing that we've put between that is also a lot longer to simulate. We don't want to bash this as hard as it can go, as fast as possible, because that's not realistic. So you've got to kind of think about how long does it take a regular person to fill this out and go through each interaction. So I hope that has been informative today, and I hope you've walked away with knowing a little bit more about load testing. That's pretty much all I've got for the load testing deep dive. Does anyone have any last questions? Sorry?
The remote machine, I mean, using an agent distributed substation, like we are executing some test cases that execution is using an agent, right? So remotely the machine will pick up and the execution is, can you use that one first?
No, no. Yeah. Yeah, so each instance, the question was, can you, if I understand it correctly?
Agent, we are using an agent, right? So the agent is like remotely.
Oh, the agent. Yeah, yeah. Yeah, so each instance is essentially isolated. It doesn't have any awareness of all the other instances that are running. And that allows us to essentially scale it without any dependencies on any other instances that are running. So you can, for example, you can share test data, but you've got to define where that gets split up between each user because they're not really aware of who's using what. If that makes sense.
I have a question about the term continuous.
Yes.
Are you implying that you let this run in a say in a test environment? As long as you wish, and just whatever test you want to do, is that what you mean by continuous testing? Remember your earlier slide?
Okay, so yeah, the question is, what do we mean by continuous in this context? So really continuous with load testing is repeating a test over and over again as the state of your application changes. So as you're building a product, for example, we can run a load test every time there's a new deploy that goes out. It could be against a UAT environment, staging environment, or production environment. The idea isn't you're trying to crash the server and bring the whole thing down and impact real customers. The idea is that you're measuring the real performance and making sure there isn't regressions along the way.
So you're better off in a production-like environment with this test than you are, say, development or production or test up.
I think generally you should always try to do load testing against as production-like environment as possible. Otherwise, the results you're going to get from that is kind of like it's one step removed from just a developer's laptop or something. So, and there's definitely ways you can do that safely against a production environment without impacting actual customers. Sorry.
For the continuous testing only, so is it just like Tosca, can it be automatically triggered by a build server? Every time a build finishes, can this be triggered and the data collected back?
Yeah, absolutely. So what will happen is that when you launch your test within Flood once and you know that it runs, we have an API that you can call to trigger that same test anytime you like.
Well, and how does it, so let's say today's world, right, where you spin up build servers, right, on the AWS or Azure,
Mhm.
then the build server runs, it triggers it, and then it vanishes, the build server doesn't stay anymore, right? If that is the situation that you're working on, will this work in the sense?
Yeah, so the question is, does the test run after your build server is no longer around?
Yeah.
So absolutely, because in our case, you're just making one request to us and we'll spin up all the infrastructure to run the test. We'll collect all the results for you and then we'll collate all those results so you can come back and view them later. And then we can report that back to wherever, or you can hit the API to find out the last result or the last 10 results or what you're looking for.
And this is basically how Tosca, those things you're spinning up, how you're collecting data from them. Do you kind of put any monitoring units back on the server itself in the server?
So at the moment we don't, but that's something that we're considering adding in the near future. So you had one last question. Yep.
I'm still having a hard time positioning the skill set needed for these tests. Typically, post testing is a very specialized skill.
Mm-hmm.
And the typical black-box type tester is not necessarily dabbled in this. Where would you position this product?
Well, so the question is, where would we position load testing as a skill set on a testing team? So really, I think it comes down to who's going to be most impacted by the results. So it's going to be hopefully closer to engineering than testing. Developers, yeah. I mean, you can obviously run the test and then hand the results over, but ultimately you want to keep the feedback loop as tight as possible so that you can make changes to correct the behavior and so forth as your tests are uncovering new discoveries.
So on this,
Yeah.
was that, I think one of the things you were talking about is, and I'm talking specifically with Tosca one, right? You're talking about Tosca, which basically is supposed to be agnostic of your technical knowledge, right?
Mm-hmm.
If I'm really using Tosca, how much is it? Do I really need, even for performance testing, am I not taking out the technology needs of the person developing the performance test? Because I'm reusing Tosca scripts, right?
Yep.
In which case, do I really need developers? I mean, just
Well, yeah, so the question is, do you really need developers working on your tests?
yeah. I mean,
Yeah.
if I'm really reusing Tosca, I'm not talking about the flood code, right?
Yeah.
That's the question I'm facing right now, right? If I'm going to go with Tosca, and does it make sense for me, but there's a different test skill set, or is it something I can use?
We're definitely positioning this as something you should be reusing. The idea is that, for the first time ever, you can kind of go from functional directly to performance tests without kind of any translation layer in between. And that's the real step up from what's been available previously.
May I add something to that?
Sure.
Out of experience?
Yep.
You need a certain skill set to do test automation, period, okay? But performance testing is a specialty inside of that as well.
It is, yes.
So I would take your experience validating testers and then ask them to lead in that particular area, and I think that makes take this to straight, Bob is not holding this.
Yep. Yeah, we recognize, and to rehash the question for the video or the statement more, I should say, is that performance testing is kind of a subfield within automation testing, and it's a very specialized field. So we recognize that with flood, there's a certain level of education that has to come with understanding the results and figuring out what you're going to be testing, and that's something we're always working on improving. And we have a very vast library of resources for learning about performance testing, and we've also got very experienced customer success teams who work with our customers to basically make sure they hit the ground running and understand what's actually happening and get results that mean something for their business. Cool.
So I'm one of those black box testers that really don't know a lot about code.
Okay.
I picked up after 8 years of working, learning how to read it,
Yep.
really know how to write it. You're saying that you're taking the UI made test cases and bringing them over and building them into this API.
Okay, so there was maybe a little bit of a confusion there. So the question is, are we taking the UI test cases and turning them into load tests for API? Is that right?
Well, you're saying you're taking the UI test cases and bringing them over into load tests.
We are doing that, yes.
So you're just basically grabbing those test cases and dragging them into the execution list.
Yep.
How are you designating that to be a load test execution list?
Okay, so the question is, how are we differentiating what execution list is actually for a load test? That's actually, I might have skipped over this a little bit too quickly, but essentially when you create a new execution list item now, you can go create load stream. So the load stream is what differentiates this being a load test. And this is where we then pull in all of the results from flood to indicate that this is, that's what ties it all back together. So you can drag any of your test cases in here for browser or API, have them both together, and hit go, and that's your load test.
I was just missing that one point.
Yeah, awesome. All right, everyone. Thank you so much for coming along and bringing some good questions as well. Hope that was informative. And if you have any further questions, find me around the hall and drop by the load testing booth. The rest of my team will be more than happy to give you a demo or answer any questions. And yeah.